Hi, I'm Jens Alfke, mobile architect at Couchbase, and I'm introducing the newest member of our client database family, Couchbase Lite for C. I'm going to start with an overview of what exactly this is and what platforms it supports, then talk about some of the issues with the API transition, since C is a very different language than the other ones that we've supported so far. Some particular issues working with queries and with blobs. And at the end, I'll talk a little bit about other language bindings, which the C interface makes possible. So the overview, Couchbase Lite, as many of you know, is an embedded database library. It's for mobile apps primarily. It also runs on desktop. It has the same basic database design as Couchbase Server does, which is that it's a document database, mapping keys onto JSON objects. It supports MVCC, so concurrency control, revisions. The queries use a SQLite-like semantics, supports full text search, and binary blob attachments. And of course, the big important thing is that it syncs with the server automatically so that you can have the same data on a client device as you can on the server. Over time, we've added more platforms to this. We started out in 2014 supporting only iOS and macOS and Android platforms. Later on that year, we added support for .NET, i.e. C#, including Windows. In 2018, we added support for the Swift language on the iOS and macOS platforms. And then in 2020, we added a pure Java version that works not only on Android, but on other platforms that run Java. So one gap in our platform support that people have asked us about is embedded systems, things like Raspberry Pi and Arduino, the ESP32. There's a whole ton of these systems which are not mobile. Well, they are mobile, maybe. I mean, they're in light bulbs and things like that, but generally smaller scale things. This really covers a vast range of stuff, all the way. The lowest end Arduino platforms have only a few kbytes of RAM and are 8-bit CPUs. In the mid-range, you have quite a lot of systems with maybe a couple hundred kbytes of RAM, 32-bit ARM CPUs, but no MMU. And way at the high end now, you have Raspberry Pi, which with version 4 has gone all the way up to an 8-gigabyte system with a 1.5 gigahertz CPU and 64-bit ARM, which is practically a desktop caliber machine, although the lower end Raspberry Pis are a bit more limited, only supporting, I think, down to half a megabyte of RAM at the, or sorry, a couple hundred megabytes of RAM at the smaller ones. So the primary criterion that we found important for deciding what we could reasonably support with Couchbase Lite was, does it have an operating system? If it has an operating system, we think we're good. Otherwise, we're not able to support it yet, although we are actively investigating some of these smaller systems. So by operating system here, what the important features that we need are like having tens of megabytes, roughly, of available RAM, preemptive threading, a real file system, TCP/IP networking, TLS support, obviously, and not having a different API on every different board, as is pretty common in the smaller scale embedded systems. The OS that really worked well for this is embedded Linux. It's already really well supported on quite a lot of embedded boards. Raspberry Pi, obviously, but there's a lot of others from BeagleBone and other developers that run Linux. You're pretty isolated from all the hardware idiosyncrasies when you're coding to Linux APIs. And of course, these system APIs are very close to Android, which is a Linux distro, and pretty close to iOS and macOS in that you have the POSIX. So we already have good support for those APIs. And Linux is also well supported by the libraries that we depend on, such as SQLite and Embed TLS and such. So we are introducing Couchbase Lite for C as part of our version 3.0 release this year. And it is cross-platform. It has the same feature set as on every other platform. It's a native library. It's like depending on your release or platform, it might be a shared or dynamic library. Minimal dependencies on other stuff in the OS. There's no language runtime needed, unlike other languages like Java or even Objective-C. But it's not just for embedded systems. So it actually runs on the other platforms that we support. And you might consider using this on multiple platforms, since it is cross-platform. You could just use the same C API everywhere. You could even write code in other languages if you made your own bindings using FFI, like Python or Rust or such. And that is a topic that I'll talk a little bit more later. The cons are, though, that you would have less platform integration. For instance, the networking code in Couchbase Lite for C is written straight to the POSIX socket APIs. And on some platforms like iOS and Android, there are higher level networking APIs that the vendor strongly encourages using because you get better performance or better mobility support or things like that. And you're not going to get that with Couchbase Lite for C. It's also harder to use C APIs than these cushy object-oriented languages that people tend to use for apps because C. So let's talk a bit about this API. Building is pretty straightforward if you're used to C code. So you just need to include the umbrella header to get all the APIs. And when you're building, you simply need to point your compiler at the appropriate paths that have the header files and the library file. So the API is the same, and I'll just cover it at a very high level. You have a database, of course, is your central object, the persistent storage for all of your documents. Each document is a named container for JSON objects and also optionally binary blobs. You have a query system that lets you do pretty sophisticated querying using SQL-like semantics, and even have live queries that can notify you when they update. And then there's the replicator that runs in the background and will sync changes back and forth between your database and the server. So the language now, of course, is quite a bit different. C doesn't have objects, it doesn't have closures, there's no garbage collector, it doesn't have exceptions, et cetera, et cetera. So we had to make some changes in the presentation of the API. So we are using opaque structs to take the place of classes, functions, of course, for methods, callbacks. You have to do your own retain and release to manage the lifetime of some of the objects. You have to check error codes. We have a different string type than you may be used to. And we have a procedural API for dealing with collections like arrays and dictionaries. And I'm going to dive a bit into each of these in turn. So you may be wondering, hey, what about C++? Like, that would provide a great object-oriented API onto this. And just hold that thought, because there will be something about that later. So let's talk about classes and methods. And throughout this, I'm going to be using Java as sort of a comparison of the way we designed the API on other platforms. So in Java, we have a class called database, and you just like declare a database instance. In C, it's pretty close. We have a struct, an opaque struct called CBL database. We don't, in the interfaces, declare the struct at all, so you can't actually see what's inside of it, but you can declare pointers to it. And so the pointers are the way that you will reference objects of those types. In some cases, like with CBL document, there's a mutable subclass of it in the API. And we were able to use a bit of the subtyping that C provides here, that a const CBL document pointer represents an immutable document, and a CBL document pointer without the const represents a mutable reference. And that helps clarify some of the functions so that we don't have to have yet a separate type and not having to cast between them. So for instance, get document would just return an immutable document, it's a const reference. Whereas get mutable document returns you a mutable CBL document reference. And the different things you can do with mutable documents are that you can pass them to some of these functions that will only accept a mutable reference, like set properties. If you just took the reference that you got from get document, you could not pass it into set properties. The compiler would complain that you're passing a const pointer into a non-const parameter. So we have some good type checking there. Methods turn into functions, obviously enough, and we've tried to be extremely regular with the naming here to be clear. So every function has, its name starts with the class type that it operates on, here CBL database in this instance, and then underscore, and then the actual method name, get document. And the first parameter to the function is the object that it acts on, the database in this case. And the regularity makes the API easier to remember, and it also is helpful when creating bindings to other languages. So listeners, the observer APIs that let you detect when things have changed, are done using callbacks instead of lambdas or blocks. For example, in Java here, this example shows adding a change listener in the form of a lambda, using that dash greater there to indicate a lambda object. In C, this is done using function pointers, and this is an approach that's really typical. So if you've used a C API before, you've probably done this kind of thing, where there's a function that you need to declare in your own code, and one of the parameters it takes is called a context, just a void star. And when you register this callback function, you pass it a pointer, that's that address of my state at the end there. And that value, that pointer will get passed into your listener when it's called, and that lets you get at the context that you need. Memory management is a bit trickier. So in Java, of course, you have a garbage collector. So you can get an object, get document, creates a new document object and returns it to you, and you can use it as long as you need it and then just forget about it. And even the languages that we've supported already that don't have garbage collection, such as Swift, for example, they manage the retaining and releasing of objects for you, so you can pretty much code the same way. That's not true in C. So in this case, when you call get document, that CBL document is a new object, and you need to free it in typical C style. Actually, it's called release. So you would call CBL document underscore release when you're done with it. So pretty much all of the objects that we have in Couchbase Lite are ref counted. And it means there's a function for each of them called retain that will bump the ref count up, and one called release that will lower the ref count and free it. Most of the time, you'll just be calling release, but there are places where it's useful to call retain as well. There are API functions that will return a new reference to you, and when you have called one of those functions, you are then responsible for releasing that reference, that pointer, when you no longer need it. And you need to check the documentation or the header files that all the functions will be clear when they need you to release that reference that was returned. Error handling is different. So typically the higher level languages will use some form of try catch error handling, where you can write all of your code without thinking about errors and then wrap it in some kind of catch block that will deal with the errors that come up. In C, this is more manual again. We have a struct. We define a pretty simple one called CBL error that just defines an error code and a domain, like a namespace for that error code. And functions that can return errors will take a pointer to one of those as the final parameter, as you can see there in that call to get document. And if the return value of the function indicates that it failed, then you can look at that error to see what went wrong. And you'll need to put that kind of an if statement after all of these calls. These rules they're used in a lot of places. We got them particularly from Apple's APIs, the Core Foundation and Cocoa. So the last parameter of the function will be a CBL error pointer. You will have a local variable that's a CBL error and pass that in. Or you can pass in null if you don't care what the specific error is. The return value of the function indicates whether it succeeds or fails. So the failure value is typically a false, null, 0. It's generally pretty obvious given the function itself, and the docs will describe what it is. So on that failure, then that CBL error that you passed a pointer to has now been filled in with the error info. If the function succeeded, then we didn't do anything to that CBL error, which means its contents are undefined. It's probably some kind of garbage that was left over on the stack. In particular, there's a common anti-pattern here, a bad thing to do to call the function and then immediately check whether the error code is non-zero. That will not work. It may sometimes work, but not in general. So you're relying on weird undefined behavior. Don't do it that way. Let's talk about strings. So higher level languages have their own fancy string classes, Java, Swift, Objective-C, C#, which makes everything pretty easy. In C, we have the native C strings, just pointer to character. And we have gone with something slightly different for purposes of language bindings mostly. So you'll need, when you pass a string literal in, you'll need to wrap it with this flstr macro that converts it into our string type. The type is really simple. We call it flSlice. It's just a pointer to the beginning of the data and a size field that tells how long the string is. And this type is used in a lot of languages like Go and Rust and so on. Slices are a very, very useful data structure. So there's a type def for this called flstring, which we'll use generally when the slice is meant to contain UTF-8 text instead of just arbitrary binary data. So why did we go with this instead of char star? We wanted to be language and framework independent, since one of the purposes of Couchbase Lite for C is to create bindings to other languages. And it turns out that a lot of the string implementations in different languages and libraries don't store the strings in null terminated form. And that means that adding a null byte onto the end of a string to pass it into a Couchbase Lite API would be pretty expensive, because you have to copy that string somewhere, which usually involves allocating dynamic memory. Put the null on the end, pass it in, and then free that memory that you allocated. And this gets pretty expensive when you're doing it on every single API call. Another reason is that with the slice, there's no magic 0 byte at the end, so it supports binary data just as well as it supports text, which is useful because we use the slice type in our blob API as well. And a minor benefit is that getting the length of the string is trivial. It's just stored right in it. You don't have to do this O of M strlen call. This string class, the slice class, comes from Fleece, which is a data serialization and collection library that we use. Now, in some cases, strings get returned to you. And if they are strings that were allocated for that call, then you need to free that memory somehow. The string will get allocated on the heap, and you'll need to free it. There is a sort of subclass, in a way, of flSlice called flStringResult, which is returned from some of the API calls. And if you get one of those, you know that you need to call flSliceRelease when you're done with it to clean up that memory. So the collection classes. Documents contain JSON, basically, strings, numbers, booleans, null values, arrays, and dictionaries. And the top-level contents of a document are a dictionary. And C doesn't have these types, really. Most languages have collection classes that will do the work of representing this, but C doesn't. So again, we've turned to the Fleece library we wrote, which is already in the core of Couchbase Lite, serving as our data serialization and JSON parsing and so on. It's got some benefits over JSON, but that really is just a matter of the implementation. It doesn't matter at the API level. So we're exposing this collection API from Fleece in Couchbase Lite for C, which explains why the name prefixes are different in this. You'll see FL instead of CBL. That's because it comes from this underlying Fleece library. There's sort of a class hierarchy here, and even though they're not literally classes in C, with FL value being a sort of a generic object type, and it has particular subclasses, FLDict for dictionaries and FLArray for arrays. And these also have subclasses for the mutable versions of these collections. These types are actually type defs for opaque pointers, where a null value means that a value is missing. Like if you get something out of an array, then there's nothing at that position, or you get a key out of a dictionary that doesn't exist. Generally, it's safe to pass null for any parameter, and it's safe to cast anything up to a superclass. So if you have an FL mutable array, you can typecast that to FL value if you need to make an FL value call on it. I'll show an example here, not really meaning you to read through all of this, but just to give an idea of what it looks like. It's obviously more verbose than it would be in JavaScript or C#. But it's pretty clear to read. First we get the properties of the document and get this FLDict object. We get the int value just as a scalar directly out of that FL value. If the value weren't an int, then the default error behavior would be just to return 0. Similarly, we can get a string from that dictionary, pass in the name key, and get back a value from that we then extract a string from. And again, if it's not a string, it'll end up being null. And then we get sub-dictionary location, or an array, location, and we get latitude and longitude numbers out of that. So it's verbose, but it's a pretty clear API to use once you get the hang of it. So I want to talk about a couple of the changes at a higher level in the API to sort of the actual way that the API presents itself. In queries, there's some good news and bad news. The bad news is that we don't have the query builder API from the other platform versions of Couchbase Lite. Mainly because it's a pretty large API with a lot of classes, and if you converted that into C, it would not be clean at all. Part of the reason that API works is because of the sort of fluent style where you can chain method calls together, and that really doesn't work in C. So the good news, however, is that to replace this, we actually built a nickel parser, and so you can create your queries as nickel strings, same way that you would on server. And we actually ported that nickel string API to all the flavors of Couchbase Lite in 3.0, so you can use it on all platforms if you end up preferring it to the builder. Here's an example. We call CBL database create query, and you'll see we're passing in an enum constant saying that we want this to be a nickel query. And it's a pretty familiar looking, if you've ever seen any SQL, this will look pretty clear. The one odd thing here is this from underscore. Now, since this is a call on a database, and a database is just one namespace, there really isn't any from that needs to be specified. You don't have multiple tables or anything like that. However, in the future, we do want to add collections similar to the collections feature in server, which means that there will be multiple namespaces. So we still want to provide, require this from parameter, but we're using underscore here as a placeholder. You could also use the name of the database, like literally this, the string that you used when you opened the database. That will also work as the value from in this case. So to call this query, we put some parameters in it, those $sign values. And so first we need to set values for those. And we're going to use the Fleece API here to create a dictionary. First we create a new mutable dictionary. We store the first zip code and last zip code values in the zip0 and zip1 properties. And then we call CBL query set parameters to tell the query that those are the parameters. And to run the query, we just call CBL query execute. And the CBL result set is sort of an iterator over that query. So we can step through it and look at the value at each index. Each one of these is a row. And so we can call value at index while the result set is parked at that row. So we get use 0 to get the first value and 1 to get the second value. Okay, blobs, also a little bit different. So blob reference in a document is in reality a special dictionary with some magic properties in it. So the CBL blob type is really a shadow for an FLDict. So in this API, you have to do a little bit of your own translation to get from where the blob is in your document to this CBL blob type. So I'll show you an example here. So first we have a document, and we get its properties on the first line, getting this root value. Then we get the photo property from the root. And we happen to know that photo is a blob. So, but we have it as an fldict right now. So we can call fldict get blob, and that will return that blob dictionary exposed as a blob object. And now we can do things like call cbl blob get length, cbl blob get content to get the blob data and metadata. On the other side, to create a blob, first we're going to create a document, and that's on the first line. We get the properties of a document as a mutable dictionary. We create a blob given the data, and you see the first parameter here is the MIME type of the data. Then we call fl slot set blob on the dictionary with the picture property to store the blob. And then finally, since we created that blob, we have to release it to balance out the ref counts. All right, and for the final section here, I'm going to talk a little bit about other language bindings. So the first thing, a while back, somebody in the audience interjected, hey, what about C++? And yeah, clearly, if you sat through the whole description of how primitive C is and how, well, a little bit clunky it makes the API. If you're a C++ programmer, you're probably really hoping that you don't have to do that. And yes, you don't have to do that. We have a C++ API. We use it, but we don't officially support it. It's not the official API, but it works. It's header only, so all of the code is very easy to see, and you can change it if you want. It's definitely higher level. It exposes all the classes as real classes. It uses smart pointers to do automatic retain release, so you never have to worry about calling release on stuff. It automatically checks the error results from the function calls and will throw C++ exceptions if they fail, so you can use try-catch exception handling. You can use lambdas for callbacks, so you don't have to manually pass context pointers around. And the Fleece API also has a C++ wrapper that lets you treat these dicts and arrays and values as objects with, subscript operators and such to make them behave pretty nicely. In fact, I'd say they're even more convenient to access than the STL collections are. And other languages are definitely possible. As sort of a proof of concept while developing this, we built some bindings for Python and Rust and Nim, which is a lesser known language, but one that I've kind of been smitten with lately. You can think of it as a little bit like a Python-like language that compiles to native code. It falls kind of somewhere in the kind of Go and Rust category. It's definitely easier to use than Rust and a bit faster than Go since it doesn't use garbage collection, but something you might want to check out. All of these are definitely unsupported. They are incomplete. They have not really been fully tested. They're mostly proofs of concept, but that we know people have asked us several times, many times about Python and Rust bindings in particular. So we think people will find these useful, and they are open sourced, they're in GitHub, and we would love to take pull requests for improvements and bug fixes. And you can write your own. I hope you get a sense that we've paid a lot of attention to making this API very clean and regular. And that means it's easier to write bindings for it. We found it quite easy to write the bindings that we wrote, and other languages should work pretty well too. So we'd love to see an ecosystem of other language bindings for Couchbase Lite for C. That is the end of the talk. I hope that you have found this useful. I hope that you will try out Couchbase Lite for C. And if you have further questions, we will see you on the forums. Thanks a lot.